I'm not convinced the air conditioning's on at all in here today.
Oh my gosh, that's illegal.
I agree. Y'all try being in menopause and no air conditioning on.
Maybe we should do a petition for that.
I don't think it's going to do anything there either. Took me weeks to get those lights fixed, so I don't even know how long it will take to get air conditioning turned on.
They need to get a personal thing.
All right, questions.
Uh,
All right, let's look at homework. So what kind of issues we have with homework?
What were the exceptions that we had to know? The H's?
What, you mean the two that won't have 8?
Yeah.
Hydrogen and boron.
Boron.
Boron will, B. Will only have 6 electrons.
It will only have 6. Just let me know. That's going to be on the quiz. Boron.
I don't know. Might be, might not be.
Please, just give me that one.
Like, I'm confused on, wait. Can you draw one with boron, the boron one? Is it like, it doesn't matter how many borons there are, we're only gonna have 6 of each one?
It will only have 6 electrons. It won't have a double bond or anything like that.
What?
There it is.
Yeah. What are you doing?
All right, so those are in columns like your homework is done. So in the first column, all right, it asks you the bond type. So I wrote bond type, so polar covalent. All right, and you have to write the covalent because it's asking the bond type. The middle, I drew the Lewis structure and I gave you the geometry. And then the last column, you don't have to write covalent because you already know it's covalent. And you can write polar or non-polar. All right?
Oh, this was number 2 was the one that you were talking to us about yesterday.
Yeah, because you get 0 when you subtract. If you get 0, it can't be polar. It has one more.
Wait, what?
I totally forgot she told me.
Remember, when you subtract and you get 0, it cannot be a polar molecule. You have to get at least 0.1 for it to be polar.
Do you like spaghetti?
Yeah, it's okay.
I like the words.
All right, is everybody checked?
Yeah.
All right, here's the next 3.
That's why I finished the essay for AP Lane, and then I was resting my hands, and then I remember I had a chemistry over time. Boy, I was hot, I was heated, but I finished it. Keep me, I don't know.
Is CH4 the same? Wait. Oh, wait, I never mind.
So you can do that.
I'm going to put the staples in. Oh, and by the way, I didn't shorten the test. It's still 51 questions. I looked at it and there was nothing I wanted to eliminate.
For number 2, it was triangular plan.
So what now?
For number 2.
Oh, triangular pyramid.
Which one are we looking at? Number 2 back here?
Oh, yeah.
It's got lone pairs right there in 3. So it's 3 and 1, so it's triangular pyramidal.
That's the only one I can't remember.
All right, there's the next 4.
So 3, 2 and 3 was triangular pyramidal.
I know 2 was because we just did that one. What was 3? Tell me the compound.
Or ASCL3.
Yeah, ASCL3 will be triangular pyramidal. Now, I will tell you the day of the test, I won't be here early, so if any of you get here early and want to come on in and start the test, like at 8:10 when they release you, you can. You don't have to wait till 8:20, I'll let you start early. So those of you who always moan about the time, hourly or something, that's no good. If you want to get here early and start, you can.
For the quiz, are you giving us one of those?
Let's use your electronegativity sheet.
Okay.
Last two. Yes. I'm just assuming you're gonna make it up.
Yeah.
Because I don't keep it to different. Should I just erase it? Okay.
Now, you have to go to the test on Monday. You will not be exempt from that unless you're just not here. All right, I gave you one. You said Gert would be here, so I gave it to you ahead of time. What?
Are you staying today?
I will be, but I'll be honest with you. I fully expect Miss Curry to make an announcement and tell us we can't stay.
Why?
Because the line of storms will be approaching. So
Friday?
I'm gonna stay on Fridays.
No, not on Friday. It's supposed to, today, it's supposed to be.
It's supposed to storm this afternoon. And a lot of times when there are strong storms or we're under a storm watch, she tells us all that we can't say and y'all have to go home. So I'm anticipating that she will do
You
it.
stand up, Fred.
Huh?
Can I feel like it at all?
She has not said it yet,
Wait.
but I'm
That's the case.
anticipating that she will say that. If she does not say that, yes, I will be here. Okay? So just listen to the announcements and see what she says. If she does not say it, yes, I will be here. But given they're calling for strong storms this afternoon, I'm anticipating that she may very well say that. Okay? Does that answer your question tonight? I mean, if she doesn't say it, then, I mean, they're not calling for storms until probably 5 or 6, 7 o'clock at night. But they're saying it could be prime time trick-or-treating hours. So,
I'm trick-or-treaters would be sad.
yes, they will be sad.
Nah, some of them still gonna be out there.
Let's still be out there though now. Hey, the rain don't stop.
The weather guys are saying, be careful trick-or-treating tonight. So I'm anticipating that if it's that time period, then Miss Curry may tell y'all to go home.
I'm still gonna be there.
All right. Questions on anything in homework that we need to talk about?
Would they hand out hot dogs?
Who hands out hot dogs?
Gas station, it's over.
All right. I'm taking this as a no on the questions.
No.
Which one? The NCL3? It's the same thing like pH3. When you subtract, you get 0.
Yeah, but.
Because you get 0, it's nonpolar.
I mean, they have both those. Now, let me see if I'm seeing
Yeah, Elijah.
Oh, I'm sweating.
When you look at the molecules,
Like,
if you have molecules that have the same bond, SO, 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 when you subtract, that's a dipole. The electronegativity difference, the number you get, is a dipole. If those numbers are equal, that's one thing you need to be nonpolar. The second thing is they have to pull in equal and opposite directions. So if they have no lone pairs, they do that. So if the bonds are all the same elements, and they have no lone pairs, those two things, it's nonpolar. So because all of these are SO bonds and there's no lone pairs there, it's nonpolar. Okay? This one has a single bond. There's no central atom. So you have to fall back on our 4.0 to 0 scale and just subtract. This one, 2 bonds, CO, they're the same bonds, no lone pairs, it's nonpolar. This one, you have 2 bonds that are the same, so we meet number 1, but these have lone pairs right there, so they're not going to be able to pull in equal and opposite directions, so that makes it polar. You got to meet both requirements. Now, the 2 exceptions that we talked about yesterday are if you subtract it, you get 0. Those don't pop up very often. I might do it to you only because you have the electronegativity chart in front of you. The state's not going to do it to you unless they give you those numbers so you can see it. Okay, so when you subtract N and Cl, you get 0 here. See how it's nonpolar? If it's 0 when you subtract, it has to be nonpolar even if you have lone pairs because you have to have at least a 0.1 when you subtract. If you get 0, it can't possibly be polar. Alana.
can you do an example of
Octahedral has 6 on it. It just has to have 6 things going around. It's the only thing that'll be octahedral.
What about the triangle?
Octahedral should slap you. It has 6 atoms.
What's the unit?
It doesn't even matter about the lone pair. pairs, it won't have any, it has 6 atoms taken off of it. You can get octahedral from the formula. You can get octahedral from the formula, you don't even have to draw that one, because it'll have a subscript of 6 on it.
Is there ever gonna be one with more than 6?
Yes, but not for y'all,
Oh, for
because that's 2 lone pairs.
I'm glad
You said
Is it 2 lone pairs right there? Makes it whole. It's got lone pairs.
You said for the ones that don't have such odd, we just subtract them.
And look at the scale. Yes.
All right.
Alright, you need your electronegativity tables. And that's all you need.
What if I have a calculator?
If you need a calculator, then get a calculator, but you just need. Yes.
Oh, yeah. I'm sorry, it's hot, my hair's falling.
It's okay. Esther Prynne wasn't all that nice to look at. She didn't worry about keeping her hair all up.
Who?
Esther Prynne.
Ooh.
It's got a letter check.
Oh,
At least learn her name.
wait. Oh my god. The hot air is gonna make me tired and I'm gonna fall asleep.
It is hot here. I won't
It's
deny
making
that,
you
but-
having
a moment right now.
You don't need
I'm
it.
trying.
Are you thinking? Sure. Equal opportunity, girl. Feel good about it, I give it to you. How you feel about that costume party yesterday? How's the homework? You tell me.
It said like my name about her trying to do it.
Welcome. You got it, Zara? Found it? You need me to give you one? Okay. Here, walk over here and get it. There you go. I need to make y'all a new periodic table while I'm thinking about it for the test. How's that on the back? Periodic table slash. Huh? Okay, as long as she doesn't make that announcement, I will be here today. Okay, it's just about whether or not she says, can't stay.
Bless you.
Bless you.
Bless you.
Okay, over there.
No.
No. No, the only thing you missed yesterday was homework.
What is number 4? Is that a VR?
I think so. Let me look. That's what I remember. Yep, BR. It's just a smudge in the copy. Probably something on the printer. All right, who's still working? So I got about 2 hands. All right, are my last 2 done? All right, so patch purpose to the front. so I can put Ellie to sleep this evening. Do you need it? Okay. All right. I'm going to put it on my solar laptop now. Put it up. All right, find your notes.
What we doing?
Take your notes.
Do we need to be cleaned up out?
Here at the table for electrons.
For our permission to open Franklin's text message.
Do you have permission to do what?
Open Franklin's text message.
Yeah.
Oh, he must be watching the video because he said bless you.
Tell him as well.
Thank you, Franco.
Hi, Franco.
Cannot get to a calculator. You're not healed.
He wants a calculator.
That's what he said.
Like, hey, can you give me a calculator, please?
All right, so we're done with covalent bonding. We need to do a little bit with ionic bonding, and then we're going to talk about the properties between ionic, covalent, and metallic today. All right. Tomorrow we have to do van der Waals forces, and then the test is Monday. We're going to have very little time, if any, to review. I'm going to hand you a little bit on Chapter 5 review, which technically is periodic table review tonight, along with your homework tonight. The review sheets, again, are not required, but I will give them to you. I will be posting answers online for you to study for the test, okay? And that way you have that and you can be working on it.
Is the test Monday?
The test is Monday, okay? And normally I would build in another day for review, but this semester is a shorter semester to be able to squeeze in exams before Christmas, and I just can't put another day in for review. All right, so ionic bonding. When we talked about ionic bonding, I don't even remember, probably late last week on Friday. Nope, wouldn't have been Friday, would have been Monday, I guess. Might have been late Thursday because we talked about the definition on Thursday. We said electrons are transferred. We said lost or gained. Okay? So if electrons are transferred, lost, or gained, we cannot show this as a Lewis structure. Okay? We cannot show as a Lewis structure. Why can we not show this as a Lewis structure? What does a Lewis structure show? Show share. Okay? We cannot show it as a Lewis structure. Lewis shows shared electrons. Okay? So we cannot show it as a Lewis structure. We have to show it a different way. So, how are we going to do this? Well, we sort of illustrate this with, it's like a balanced equation. All right, so we call these ionic representations. Doesn't really have a name. All right, doesn't have a name per se, but it looks sort of like a balanced equation. So I put that there to sort of give you an idea of what it looks like. So let's say that we're going to draw Na plus Cl, so sodium chloride. I'm going to do it on the next board. I know I'm going back. I meant to erase and I went crazy. So I'll let you catch up, but I need to write under it. It's going to get too small. All right, so tell me when you guys are caught up.
Is it ball EQ?
Balance equation. All right, everybody caught up now? All right, so if we take the equation I was getting ready to do, Na plus Cl yields. All right, on this side, you show where the electrons are originally. All right, so it's essentially a dot diagram. So, what do you know about Na? How many dots does Na have? This is why I said you need a periodic table.
5.
Okay,
Wait, what?
I hope not. Na is in group what?
1.
So it has how many dots?
1.
1.
I can still gotta take that quiz too.
Okay. Chlorine is in group 17. So it has how many dots? 7. Okay? So we're going to draw 7 dots.
In A.
What did you think I said?
I looked it in. That's right.
Okay. Well, that at least explains that.
Yeah.
I was afraid the heat had cooked you right.
It's getting there. Wait. Oh, no.
All right. So from there, all right, what do you know Na will do with its electron? It's going to lose it. It's going to give it away. What is chlorine going to do?
Take it.
It's going to take it again. So you're showing me that on the other side. So on this side, we're illustrating where they go. Okay, so Na plus Cl. So over here, you're going to show me that Na loses the electron, and you're going to show me chlorine gains the electron. So how do we do that? All right, so if Na loses the electron, do not draw the dots. And if you gain the electrons, you draw the dots. All right, so Na lost dots, so we're not drawing any. How many dots will Cl have if he gained one?
8.
So we're going to draw 8 dots on chlorine. Now, what's the other thing we've learned to do this semester to illustrate that you lost or gained some electrons? What's that called? That's right. Include oxidation numbers. So include the oxidation number. So what oxidation number will Na have if it lost one electron? +1. And what oxidation number will Cl have if it lost one oxidation number?
-1.
So we write -1 on it. You with me?
Wait, you mean if it got one,
What did I say?
lost one?
Oh, if it got one, sorry. If it gained one. You with me?
Yes.
Okay. Everybody got what they need off the board? Okay, tell me when you have it, Zaria.
How many minutes do you have to stay in the class in order to be counted present?
Half, so about 50.
50?
Well, it's 95 minutes. I mean, you could argue 48.
So,
But-
like, in fourth period, I can leave at 2:50
Yes.
and be counted as there.
Yes.
Okay. Sounds like a plan. Don't know how to make it all day.
Okay.
Happy Halloween.
What was that?
All right, so Mg plus F. How many electrons does magnesium have in its outer shell?
2.
Okay. How many electrons does fluorine have in its outer shell?
7.
Okay, back.
So, what is magnesium going to do?
Give it 2,
It's going to lose how many?
2, 1.
One, so it can make 8.
Because that's not.
Now, can MG only lose one?
No.
It's got to lose 2. Okay? So MG has to lose 2. Fluorine's going to take how many of them? So I got a homeless electron down here, right? It cannot be homeless. You have to add something to the products to give it a home. Now, we can either add another Mg or another F. Now, if we add an Mg, it's going to do what? Lose 2 more, and I have how many electrons? 3 homeless electrons. Does that benefit us?
No.
No. But if I add an F, F wants to do what?
Take it.
It wants to gain. It already has how many? It already has 7. So this little homeless electron can do what?
Go to the.
It can go to the F. And then it's not homeless anymore because it went to the fluorine. Okay? So magnesium has to lose both of the 2 that it has. All right? So some of y'all are thinking, I don't get it. How am I going to know how many to add? That's where I'm going with it. All right? So how do you figure out how many Fs or Mgs or whatever to add? What's your oxidation number for magnesium? Look at your periodic table. Tell me the oxidation number for Mg. What?
2.
What's your oxidation number for fluorine?
7. No, 1.
Negative.
It's negative.
I got one little voice out there.
It's negative.
It's -1. Now, what do you do with that +2 and -1?
Crisscross.
So you get Mg1, F2, and I'm emphasizing that 1, which is why I wrote it. So on your product side, how many Mgs should you have? How many Fs should you have?
That's all right.
You should have 2. Okay? The subscripts tell you how many you need to make the electrons work. Does that make any sense? Okay. So let's say
Wouldn't you do that first?
you could, sure. I'm just showing you how it relates. So let's say we have K plus O. How many electrons does K have?
1.
How many does O have?
6.
All right, what's going to happen?
Okay, so then they give it the electron.
Okay. So K is going to give 1 to O. So now K has a +1. O has how many?
Or 7.
Has 7. Now, if K only has 7, is it happy with only having 7?
No.
No. It wants how many? It wants 8 also. It's only got 7. What are we going to do? Add a K. Now, Zyra had no trouble spitting out add a K. But let's say, I'm Sam back there who's propped on her arm debating whether she's going to fall asleep or not. All right? And tomorrow she can't remember. But she remembers that oxidation number stuff. All right? Sam could say K has what oxidation number? 1. O has what oxidation number? 2. What do I do with them? 2 and 1. How many K's do I need? How many O's do I need? So what do I need over here? How many K's do I need? I need 2 K's. So I need to add a K. And I only need how many O's? 1 O. Okay? So Up here, K is going to do what?
Give
Give
it.
it to
Give its electron to O. And then +1 and -2. Are you with me on that?
Yes. Wait, how do the oxidation numbers work over here on table? 1, 2, vary. 1 big vary in the middle.
And vary in the middle. And then when you get here, you say +3, plus or -4, -3, -2, -1, 0.
Okay,
That's what I
Okay? Say what? You will not be losing or gaining electrons if they're 0. They will not be part of this. Okay? Because remember, they don't want to lose or gain any. Okay? Everybody with me? Now, what's the final step I didn't show you in this equation or this equation?
put in the subscript.
Nope, not the subscripts. What didn't we do?
No, lose structure. No, you can't lose.
What's wrong with these equations?
We didn't tell them.
What, Zyra? They're not balanced.
Oh.
Oh, this is so easy. How many MGs are here?
2 minutes.
One.
1. How many are here? 1. How many Fs? How many Fs? So all you gotta do is put a 2 there.
The point is, we didn't want to do that first.
This is not hard, people. How many Ks are here?
1,
How many Ks are there?
2.
So I'll put a 2 there. All right, I'm gonna give you 2 to try. Let's say that you have to do CS plus S and AL plus F. Those 2.
Okay.
And then we'll talk about bond properties. What time we have left?
How was that?
I'm gonna see this one. No. We're not coming to see you. Why not? Yeah. I don't get it. Alright.
We done?
Wait a minute. No, I'm not.
No, I'm not.
I'm getting creeped out there. Franco was like watching. Is he even still there?
Franco, where's your school?
He might be.
Oh, there's 3 people watching. Oh. Hey, Franco.
But
hollering at Frank. The wall's not that thick. I'm saying.
There's 3 people. I just think there's one person in soccer we have, but that's okay. Who's else?
It was long.
Oh,
If you did have a soccer watching all your lives.
Okay.
Cooler
in the back room.
Cooler back.
It's cooler back that way.
For real? Can I walk back there?
We'll go back there and see if you're gonna stay.
Yes,
What is that,
well,
like
I'm
your
just gonna
teacher
sit there
area?
and stay.
So what?
Is that like the teacher?
Yeah, the copiers back there and all that.
You don't have to pay 10 cents for that copier, do you? Oh, wait.
I don't.
Hey, oh.
I
You have to pay 10 cents to print through Miss Floyd.
Yeah, that's a convenience fee.
But there's other printers.
Yeah.
So what's the point of
Yeah.
doing that? You were just gonna print.
It's better back there.
It's a lot better.
Where's? Yeah, this
The
humidifier.
dehumidifier sucking the
It's
moisture
hot.
out. It's a dehumidifier. It's pulling the moisture out of the air. It will help it.
Yeah. Better.
No, it's pulling the moisture out. All right, so cesium has how many dots? Too many?
One.
One. Sulfur has how many?
2. Oh,
It's real confident.
It's in group 16.
oh, I was, you know what? This is where I messed up.
What did you think it
I
was?
did it by oxidation numbers this whole time.
No.
Dun, dun.
Okay. So what happens to CS?
You get 2 of them.
Okay, so cesium
Yeah.
loses 1 and it goes to sulfur. So sulfur has 7 now, right? So that's why Xavier said we need to add a CS so that sulfur could have 8. And they wound up with +1s and -2. And then y'all said to put a 2 right there. Right? All right, so aluminum has how many electrons? 3. And fluorine had 7. So aluminum does what? It loses all 3. And so we need how many fluorines?
3.
We need 3. And so we end up with +3.
Yeah.
Yeah.
I feel like.
I'm so tired.
Are we okay with that?
Yes.
Yes or no? Who's not? Yes, ma'am.
I was gonna say.
Sorry, I just put it in the wrong place. There we go. Are we okay?
On this wall.
I'm hot. Even I'm beginning to feel like my brain's going to ooze out of my ears. All right, questions? Sam, question, or are you just checking and pointing? Checking and pointing, okay. So anybody have a question?
Oh,
Are you okay with how we got the oxidation numbers now, or counted the electrons, or what you messed up a while ago?
very confusing.
Okay, so Al is going to lose 3 electrons, right? Well, 1 went to this F. So I had 2 homeless electrons, right? So I had to add an F for this one to go there, and then another F for that one to go there. All right, but if you can't figure out how many Fs to add, do what I showed you with the oxidation numbers. That had a 3, that had a 1, 1, 3. So you need 1 Al and 3 Fs. Okay, that'll show you how many to draw on the other side. Okay? Yes. When you're doing what? Oh, 2 because it's diatomic? You just don't for this because you're just showing where the electrons go in the transfer for the bond.
So you don't actually.
That's all. You don't write a 2 on it, no. Because you're just showing where the electrons go in the transfer.
So
That's
what's the answer to the thing?
What do you mean what's the answer to that?
Like, what is the answer?
That whole thing, all of that, with all of those dots drawn.
You leave them like that?
Yes.
If you leave the oxidation numbers above?
Yes, you leave the oxidation numbers above it, you leave all the dots drawn, you leave all of that. All of that belongs there. Okay? All right, so now we're going to talk about the properties of metallic, ionic, and covalent bonds. Now, I don't know how you want to do this, all right? I used to tell people to make a chart. Some people didn't like the chart. I'm going to use whiteboards or a board per type of bond, okay? Now, for the most part, I try to do all of metallic bonding before I go into covalent bonding or ionic bonding. But I'll be honest,
Why do you start with that?
because I just do.
Wait, did we just do ionic?
Yeah, we talked about the way they're represented. I can start with ionic if you prefer, but I like to do metallic so I can illustrate how it's different from what we've done with covalent and ionic, though.
That's fine.
That's why I choose to do it that way. But the problem is, you know how I mess up sometimes and y'all get upset because y'all write in ink? Sometimes I forget things and I have to go back and put it in. So after we finish metallic, you might want to leave a few lines in case I forget something. Okay?
Oh,
I'm
Lord.
just giving you fair warning.
So we doing another page? Is it a different page?
Well, you don't have to do it on a different page.
Wait, why?
You can start the properties of the bonds, but when we finish metallic, you might want to leave a couple lines because sometimes I forget.
I mean,
The properties of bonds should go on a different page, right?
Okay, if you want to put it on a different page.
Why, you might forget what?
now I'm confused.
Why are you forgetting things before you're the teacher? You're a trusted source of
No.
authority. Please don't forget it.
Why am I getting fake?
After I finish talking about the properties of metallic bonds, I'm going to talk about the properties of ionic bonds.
Did we just do
But
the
sometimes I remember something in ionic bonds and I'm like, oh, I forgot to say that under metallic, and I go back. But if you don't leave any space, you're like, Miss Wall, I have no place to write it.
Yes.
Yeah, he figured.
What did you say?
Break your back.
Yes.
Oh my God. One deeper
Yes.
or something like that.
What?
Right.
Who said that?
Me.
I know what that meant.
If it's me, so.
She told us to pick our own song. So that
All right. So we're going to talk about metallic bonds. So in a metallic bond, I told you when we defined this, that this was called the electron C model. All right. It's called the electron C model because if we look at a cross section of a metal, okay, you have a bunch of positive nuclei and you have electrons that are in the metal.
Oh, Lord.
And these electrons can move wherever it is they want to go. Okay? The electrons are mobile or freely moving. Now, this makes them very different from covalent and ionic bonds. All right? In ionic and covalent bonds, the electrons are locked into place. They cannot move. And I'll talk about that when I do them in a second. All right? But the electrons in metallic bonds are freely moving. Everybody with me on that? Now, because these electrons move, it gives metals unique properties that ionic and covalent bonds don't have. So back probably in middle school, you learned some properties of metals. Anybody tell me something they know about metals? All right, they're shiny. Did anybody give me the nice science word for shiny? Starts with an L.
Zaria has an answer.
Hold on, Zaria. Is it the one for shiny? Luster is it. All right, luster or lustrous. You can use either word. All right, what did Zaria have?
She said luster.
Oh, that was it. Luster or lustrous. Very good. All right, anybody got another one?
For shiny?
No. What are the metal properties? I got that one.
Hard.
The what? They're all solids. They're all solids except for one. Can anybody tell me the one exception? I've already learned it.
Hydrogen.
Hydrogen's not a metal. H is what?
Liquid.
Yes, it is a liquid, but what's it called is the name. Mercury. Except mercury. Mercury's a liquid. They're all solids except that one. Huh?
What if I just put my finger in somewhere?
Well, you could absorb it through your skin and give yourself mercury poisoning.
Oh, God.
Precious.
That elevated.
Yeah, are you, I think you're on, did you serve detention?
Yep, I did.
No, you didn't. I haven't seen you for lunch.
Yes, you did.
When did I see you?
I don't know. I came in with BBD. It was like 7 minutes left.
Oh, yeah. I knew
Alright.
that now. So that means we have to do it again?
Yes.
Yeah.
You didn't like your lunch table, Precious?
It was fabulous.
Miss Wall, I gotta come bring lunch today to take a quiz.
Oh.
I keep forgetting.
And you've been with me.
Miss Wall, I gotta come.
Alright, so what other things do metals do?
Squish.
What was the question?
We're looking for some metal properties. There's one that I'm expecting y'all to get. The other two I'm not expecting. We're going to talk about that. They have very high melting.
That's three, actually.
And boiling points. And the reason for that is they are the strongest bond, which plays into tomorrow's discussion. Okay, they're the strongest bond. So they're going to have the highest melting boiling point. But that's still not the property I expect y'all all to know from another science class.
Let me see.
Starts with a C.
Come.
Yes.
Oh my
What you
God.
Conductive.
They're good,
Like electricity conductive?
yes, or heat.
Because all the rest of us are.
Hey.
They're good conductors of heat
Some of y'all smart.
and electricity.
It's okay. Ain't nothing-
All right. For example, I have one outlet in here that some Yahoo last year stuck a paperclip in after I told him not to do it.
Can I do it?
He did what to a paperclip?
Stuck a
Did you get
paperclip.
electrocuted?
I did
No,
that before.
but spark shot across the room. He spent the rest of the year in Jacket Academy.
Why?
He was.
He was trying to do a science experiment.
No, he wasn't. I already told him not to. We'd studied electricity. I told him
the
not
jacket
to.
for the rest of the year.
Dang, free my
Hey,
boy.
you're
Sorry.
crazy.
Free my boy.
That's what I'm saying.
Free my boy for real.
I did that for a moment.
Don't do it.
The whole thing exploded.
The outlet is permanently broke.
Oh,
Like,
the
Oh.
what?
like
The outlet.
It like blew up.
Toast.
Is it the one over here?
One over there. That one over there just has to have the test or reset button hit if it's
How
not
do you
on.
know?
Now,
'Cause I did it before.
You were the kid that
Oh,
did
no,
it
no,
with the
I
jacket
did it.
and Xavier.
I did it
there's
like,
one in every crowd.
I did it like when I was like 6.
Oh my
All right.
Yeah, you did it last year.
Metals are
I
malleable.
want to try it now you said that.
Okay. Maybe there's two in every crowd.
You don't like close my nose.
I put tinfoil in the microwave. You should really do that like that.
All right. Malleable means it can be rolled into sheets. All right. Or flat. All right. You can roll it flat. Now, ductile.
Okay, how many properties are there?
This is the last one.
We gotta remember these?
Oh, no, you can get them wrong on the test.
Oh, that's so you got the other day, they just kept adding stuff too. I was like,
Ductile means you can be drawn into a wire. Okay?
Can you explain that further? Because I do not understand.
For example, copper. Copper is ductile. We use copper in wiring. Those of you who have necklaces, the metals, for example, I'm going to pick on Daniela. She's wearing nice hoop earrings. That metal that she's wearing is very ductile. We could not draw that wire into those hoop earrings if that metal was not ductile. You know what it's made of? I can't see it from here. Is it gold? Danielle, your earrings, what's it made out of? Is it gold, silver, copper, anything? Got anything for me? I use copper because it's used in wiring. All right, whatever metal Danielle's earrings are made out of, they're smaller, thinner hoops. Okay, I can see that Janiyah has on a necklace. All right, whatever the chain is made out of is ductile. It can be drawn into a wire. All right, that's what ductile means. Anybody have aluminum foil at home?
Yes.
If you love aluminum foil like Michaela over there, it's malleable. It can be rolled flat into a sheet. All right, that's what malleable means. Everybody good with that? Anybody have some rims on the car? Like to look at rims? Those are shiny. They have good luster. Everybody good with the properties?
All cars have rims.
They're not all shiny. Black has become very popular these days instead of shiny ones. Some of them have gone to matte black. Mine are actually graphite. They're gray.
Just walk up there all cracked out.
Only so I can hear.
Oh my God.
All right, everybody caught up? All right, you got it from your friend. All right, Solonic bonding.
Who?
Leave a little space, like a couple lines in case I forgot something and I come back.
How many lines?
I don't know. I don't know. I might not have forgot anything.
Miss Wall. Miss Wall.
What?
When I asked you if we did ionic bonding before, you said yes.
Oh, no, I wasn't done with ionic bonding. I'm just talking about I was done with that part on the board.
Did we just do metallic?
Yes.
Did you forget anything?
I just said I don't know.
Okay, think about it first. Coming soon.
All right.
We was already, I thought this. Hold on. Wait, now you got me.
Happy Halloween.
I thought this.
Trick or treat.
Was all for ionic bonding? No. I told y'all I was putting the rest of ionic bonding under the properties. I wasn't putting it with that other stuff.
So this is part 2.
Yes, call it part 2 if it makes you happy.
Okay.
It's part 2. Okay? Now, properties of ionic bonds. All right? First of all, it is the second strongest bond. So that means that its melting point and boiling point, all right, are not as strong or not as high
Oh, that's why I don't look
all right, the melting point and boiling point are not as high as a metal, but still high. Okay, so they're not going to be as high as a metal, but they're still going to be high. All right, because an ionic bond is still pretty strong. Now, what makes it different from the metallic bond? All right, I have to draw a really ugly picture here. All right, and I'm sorry, but I just have no ability to draw, so y'all just have to work with me here. I ain't got very far yet.
That looks pretty
It
good.
looks
to
like a
me.
maze.
A maze.
All right,
For the top.
this whole thing is a crystal lattice.
I heard
That's good.
We have to draw that.
like,
I'm going to define it, so you. It's up to you, and I'm going to color one of them.
We gotta draw that too.
I just told you I'm going to define it, and I'm going to color one of them and define the piece I colored. So it's up to you.
I can't.
A crystal lattice is an orderly arrangement of crystals. That tells the geometric pattern. Now, I will come back to crystal lattice down the road in about, I'm guessing 2 weeks, maybe a little less, and talk about the 7 different types of crystal lattices we can have. Not going to do that today. Now, we know the crystal lattice or the geometric pattern because every crystal lattice has what we call a unit cell. Okay? Hey, I only drew little diamonds.
Your crystal lettuce is better than mine.
All right, a unit cell is the smallest or simplest part of the crystal lattice that tells the pattern. For example, if you looked at my unit cell, you should be able to tell that's a what? A diamond. So if you saw my diamond unit cell, you should know everything else is a what? Everything else would be a diamond. If it was a cube, I could have drawn one cube. I couldn't draw a crystal lattice of all cubes, which is why I did not draw a cube. They'd all been squares. All right, so if you saw one cube, you'd have known everything else in the crystal lattice would have been a cube. All right? I'm sorry. Yeah. There it is. There you go. Are we caught up? Need more time? Where are we at? Are you okay over there?
Yes.
I'm beginning to think you're in math class.
Math class.
Math class.
What?
You know how it's supposed to
that.
Right.
Young guy.
I'm supposed to know about that class.
Remember that one time that motivational speaker came and Zach there, he was like, which one y'all do math? And then Zach Bear raised his hand and he was like, no, y'all don't do math because you don't say you do math. I don't know, but Zach Bear raised his hand and said he like some bad or something. And we all just was okay with it. Like,
Remember that time we were supposed to have a motivational speaker and he never showed up?
All right, we caught up now.
Wait a minute.
From that day on, I've lost all motivation. Exactly.
They a year like last year.
they keep watching.
Gotta hate when that happens.
Little motivational speakers.
Yeah, it's terrible. All right, we there? I'm going with yes on this. All right, so
It's actually a long game. Like,
He's been brought to first place like every year.
oh, I didn't get judged.
Science said that she would
all right, so every crystal lattice has a lattice energy. All right, every crystal lattice has a lattice energy.
Oh! Why would you do
You don't even scare me. I was screaming, I can hear my ears. Like, the screaming hurt my ears.
I almost just cried right in there, like.
People, normally I'm easy to start, and even that didn't bother me.
How?
I looked up my time.
First of all, Mr. Tank too black when you went in this like.
Really?
Yes.
That screaming just scares me. I'm singing anytime I show.
You're singing?
No.
I am.
I think you should do that thing that you did the other day.
Oh,
With the-
that's
I think you should do that.
No.
I think you should do that in
I think
conversation.
I should too.
I think that was good.
I
No,
sing.
it goes.
You can't.
Somebody recognized
Second
that.
place. That you gonna get second place.
Right, I'm
He
getting
first.
first.
He gotta get first.
First place.
Wait, Keith's gotta get first. He didn't do that.
He's been robbed.
Yeah.
Matthew and he forgot this thing. He got it.
I don't think so.
All right, do you have this written? All right, let's finish this so I don't have to come back to it tomorrow.
Okay.
All right, so each crystal lattice has a lattice energy. Yo, Allie. So,
8 people's on this county. Just because it says share size don't mean I'm gonna share.
the higher the lattice energy, the stronger
The ball.
the bond.
Hey.
Mr. Tate's face out of my head.
I could barely see
Okay?
his face.
The higher the lattice energy, the stronger the bond.
I want to go to the tree.
Okay? The higher the lattice energy, the stronger the bond. Now, I'm going to save these notes so that we have them for tomorrow. We got to come back to them. Now, let's talk homework for tonight.
Let's talk about.
51. Let's talk about.
Now, I got to give you directions on these, so don't put it away.
You're giving the receipt.
Direction day.
Otherwise, y'all will all be like, I know how to do it before.
Baby.
Did Benjamin turn up his camera?
Yeah, I think so.
He did. Oh, this is gonna be.
And what's his name?
I got no
1 year.
All right.
Recite the whole year at table.
All right, number 1, word A. This is self-explanatory. Label IOC. Part B, mark out 5 and 6.
Hi, this is from central office. So we
First
Oh, Miss Harvey, you shouldn't have.
You said 5 and 6?
All right, and part B, mark out 5 and 6. That's an ISO electronic series. We're not doing it. All right, part C. And
Wait,
first
mark
line.
5 and 6 from what?
Part B, pay attention.
Part B.
All right, so let me see. On the first line, the first row, you're doing a dot diagram. Write it down. You will not remember tonight.
Dang. Where do we represent it?
Out to the side. Make yourself where? On this?
Where?
For C.
The chart. Oh my
Where?
goodness. Y'all are terrible.
Ain't no lie.
Next to the Lewis structure or
I know you did not, Ellie.
do we do it next to
Not mixed.
all the
We'll still be here in the Bell room. So out here beside where it has the chart, write dot diagram or something. So you remember this whole row is a dot diagram. This whole row right here is an ionic representation.
What is that?
We learned a while ago when we wrote Na plus Cl with the arrow.
What's the dot diagram?
Ionic what?
Look it up in your notes.
The beginning?
This right here is a Lewis structure. Write it out to the side. Lewis
Wait, what did you
structure.
say the second one was? Ionic what?
Representation.
Representation.
Holy crap.
Oh, what's the other one?
Right here, beside this section. A equals central atom. Just write Ca. A equals Ca for central atom.
A equals
CA for
Wait. X equals bonded atoms. X equals the bonded atoms. E is lone pairs.
C? You said Siri.
I can't fix stupid. There's no C's up there.
E equals
Lone pairs.
A equals.
Don't move.
All right, let's go.
So if it says AX4, A is the central atom, X are the bonded atoms. What geometry would that be?
We're gonna fail.
Yes, you are.
Tetrahedral.
Very good.
Oh,
On the back. On the back. Don't move. There's a back. It says bond polarity. What are you going to do if it says bond?
Polar?
Subtract. Write subtract up there. This is gonna be y'all at the end of the day. Molecular polarity. What are you gonna do here?
Look at the Lewis structure.
Lewis structures. Write it down.
We have to draw the little structure.
Yes, dear.
Say you better not leave.
You said, I was just gonna say the same thing.
Mr. Taylor.
Mr. Taylor, there was glue in my life. I thought
I think I was about to die.
He turned the light off. He turned the light off. Then he got the glow in the dark teeth. What is you got going on?
Bye, Miss Wall.
Bye.
Have a great day.
You too.
Same thing.
I thought there was an active shooter in the
I
building.
freaking, he looked scared me. Nah, he's not supposed to get me.
Well, he said he too black.